Hello, kid. Welcome to another chemistry class with Mrs. Tessie. Our topic for this week is density. In today's class, you'll learn all about density, its meaning, the formula for calculating density, its units of measurement, and how you can use the concept of density to separate mixtures. In understanding the concept of density, we'll first look at this activity. You take a glass cup and half fill it with water. Put a small wooden block and a stone in the water at the same time. Put the wooden block and the stone. Then you observe. Okay? Is that easy? Have you done that? And now, what have you observed? You will find out that the wooden block floats while the stone sinks. True or false? If you did your work correctly, then you will find out that what I have said is true, unless you did not do your work well. Okay? And you might want to ask yourself, what's the reason for this observation? Well, you already know that the wooden block is lighter in weight than the stone. Naturally, heavy things sink. So any solid that is denser than water will sink in the water. But if the solid is less dense than the water, then it will float. That is why the wooden block, since it is less dense, which is lighter in weight than water, it will float on the water. But the stone, stone is heavy. It's heavier than water. It is more dense. So the stone will sink. This is what causes objects to float and sink, their densities. We'll try another activity. This time with liquids. We have done something with solids, now we'll work with liquids. Get a 150 ml beaker. If you don't have this size of beaker in your house, you can get a very big glass cup. Then get 2 other small cups of same size to represent the 50 ml beaker. Now add 50 ml of water and 50 ml of oil in this 150 ml beaker. Then you observe. You find out that the oil floats on the water because it is less dense than water. Have you ever noticed that no matter how hard you stir oil and water, they never mix? They are immiscible liquids. The oil will always stay on top. But why? Why don't the water stay on top of the oil? Because oil is less dense than water. It is just common sense, right? That's the concept of density. It's like a chubby person carrying a slim person. The heavy substance should be down while the light substance should be up. Now, what then is density? We have seen examples of density or concept explaining density, but what is density itself? That's the essence of this class, right? So by way of definition, we'll now see what density is and how it can be calculated. Right? Are you ready? Okay, so let's go. What is density? Even in our physics class, we've been taught that density of a substance is a measure of its mass per unit volume. A measure of its mass per unit volume. When you divide the mass of a substance by its volume, what you are calculating for is density, the density of the substance. Right? That's easy and short. But you might be wondering also, what's the meaning of mass and what's the meaning of volume? What's the mass of a substance and what's the volume of a substance? Okay, so mass is the amount of substance in an object. The amount of what? Substance in an object. Any object at all. The amount of substance that make up that object constitutes its mass. We know the different instruments of measuring mass. We use the chemical balance. And of course, mass is measured in grams and kilograms. Grams measures small amount of mass, while kilograms measures large amount of mass. But what is volume? Volume is the amount of space that is occupied by an object. Whether the object is big or it is small, the space it occupies is its volume. If it's a liquid, for example, like your water in your water bottle, the space that that water occupies inside your water bottle is the volume of the water. So now that you know the meaning of mass and the meaning of volume, I believe you understand better the meaning of density, right? So density means comparing the mass of an object in relation to its volume. That is why you have to divide the mass by its volume. You are comparing the mass, okay, comparing the amount of substance in an object to the space that the object occupies. You understand that, right? So that's all about density by way of definition. Comparing the mass of an object in relation to its volume. How does this knowledge of density help us in separating mixtures? We learned in our previous class different methods of separating mixtures. Yes, but let's say we don't have those materials for separating these mixtures. Are there other ways we could use to separate the mixtures? Of course. With the concept of density, we can know the objects that will dissolve or sink in water and that will float, even if it's not water but any other solvent. So components of mixtures can be separated by their density differences. Okay? You already know that oil and water never mix. Oil will always stay on top. So what do you do with the idea of that density difference? You know that you carefully scoop the oil on top away, either by decantation, leaving the water beneath to stay behind. So this knowledge helps us in separating mixtures. Isn't that beautiful? We'll now look at activity 3. How would you separate a mixture of iron filings and sawdust? Without being told, before this class, we would have just said, oh, very easy, we use a magnet. Because of course, iron filings will be attracted by magnets. But let's say you don't have a magnet and you have to separate the mixture anyways. So what are you going to do? Yes? Can you think of something with this idea of density differences now? Is there anything you can think of? You simply add water to the mixture. Yes, to the mixture of iron filings and sawdust. Let's find out which one of those two components of the mixture will dissolve. Right? We know that none will dissolve because they're both insoluble solids. But at least one will settle to the bottom of the water while the other will float. The iron filings will settle to the bottom because it's heavier, of course, made of metal. But the sawdust, which is made of wood, will float. So iron filings sinks while the sawdust floats, because sawdust is still wood, shot from wood, and wood is light in weight, so it will float on the water. While the iron filings, which is made of metal, even though it's so small, it's tiny, but then it will sink because it's heavier than the water. With these concepts now, you can now carefully decant the sawdust from the iron filings. So we have iron filings in water in one cup, while the sawdust in water in another cup. Now, calculating the value of density. Let's calculate the value of density using a formula. How do you do that? Let's say you want to find out the density of a substance. You do not know whether it is more dense or less dense than another substance. How do you know? How do you calculate for it? Is there a formula? Is there a way you can tell? Or by just looking at it, you just say, okay, this is less dense, this is more dense. Is this by magic? Of course, there's a formula called density equal to mass divided by volume. This formula means that you just find out the mass of the object. After getting the mass, you simply divide the value of the mass by the value of the volume of that same object. So let's say, for example, the mass is 10, the volume is 2, the density will be what? 5. But of course, you know that units are also very important. Units are very important. That is why in calculating this, look at this question. Question 1 says, calculate the density of an object of mass 100 grams. You see, the unit of mass here is in grams, and volume 20 mils. The unit of volume here is in mils. That's milliliters. Apart from grams being the unit of measurement for mass, you could also use kilograms. That is if the mass is so big. And apart from milliliters, you could also use liters if the water is so plenty. And you can guess right, when you divide 100 grams by 20 milliliters, what you get is 5 grams per milliliter. So this is the answer. This is the density of the object. Is it simple? It's simple and straightforward. With this calculation now, it goes a long way to helping you know and calculate a lot of things. So this is how density is being calculated. And in summary, let's look at all we've learned so far. We learned what? The meaning of density, density in solids and in liquids. Then we looked at the formula for calculating density and their units of measurements. Then finally, we looked at how the concept of density can help us in separating mixtures. I hope that you enjoyed the class, right? You followed through with everything that I said. So I'm thanking you most sincerely for your time. Thank you. I hope that we keep a date next week. But before then, there is a quiz that follows. So take time, make sure that you attempt your quiz. Even if you don't get it all complete, you can try again, right? There's no harm in trying again. So thank you and goodbye. Take care until our next class.